this circuit is given, the V of S is given as 60 with the phase of 0 RMS. So Vs equal to 60, 0 degree, and it's RMS. So this is very important. Now that the voltage is given in RMS value, then you have to be mindful that, for example, if I'm calculating the current will be also in the RMS value. So just in the formula, we have to make sure that we are using the formula when we are having RMS, okay? Okay, so this is the voltage again RMS. Now we would like to find the equivalent in loading impedance between terminal A and from here to here, and the equivalent impedance. Okay, so these two are in parallel. So we know the formula. The equivalent of these two would be J times negative 0.5J divided by J plus J plus negative 0.5J. This is 0.5J, and they cancel each other out, 0.5 and 0.5, the remaining is negative beta. This is negative J and this is 2. So the first part would be from the AB is 2 minus J. Okay. Now, next, we want to find the load between B and C between these 2 points. Okay. So these two are in series. So this part would be 25 minus 5J. And then they're in parallel with this. So the BC is parallel of this to 5J times that part, which is 25 minus 5J, divided by summation 5J plus 25 minus 5J. 5J and 5J cancel each other out. 5. So J times this divided by 5, which is 5 minus J. So 5J negative J squared, which is 1 plus 5J. Yeah. So this part equivalent is 1 plus 5J. Now it says next part says find the total load seen by the voltage V of S here, Z of L. Whole thing. Z of L is basically these two are not in series, right? ZAB and ZBC, they're in series, so we'll just add them. This one was 2 minus J, the other one is 5J plus 1. So the total is 3 plus 4J. This is the L. Then it says find part D, find the RMS value for the phasor current IS. Okay, the current, as you see, the IS is here. The current that goes through the whole load. So IS is basically VS over the whole Z, right? So V of S is 60 with the angle of 0. Remember, this is RMS. And then the Z of L. Z of L is 3 plus 4J. But then because we are dividing them, we have to convert also this in the polar. So 60 with the angle of 0. And then this becomes a square root. So basically this part would be, oops, 3 plus 4J, right? This in the polar format would be a square root of 9 plus 16 which is 5, with the angle of, this is 3, this is 4. So the angle would be tangent inverse of 4/3 in degrees. It's apparently 50, almost 53 degrees. So therefore, this I can write 5 with the angle of 53 degrees. Okay, so you divide them, you get 60/5, which I think it's 12, with the angle of -53. And this is RMS. Again, I will put it here, RMS. Why RMS? Because the voltage was RMS. Oh, sorry. Disconnect it. Yeah, because this was RMS, because voltage was RMS, and the current is also RMS. This is the current. So we are done part D. Part E, the average powers associated with ZA, B, ZBC, and ZL. Okay, so we have the load, and then we want to find the average power, P. And in this case, we have the Z, we have the load, and also we have the current. So, and I can go from this formula, and because this is the power P, if you remember, there is a formula that if we have a load, let's say Z, as R plus J, real part and imaginary part, then you can say P is equal to R, the I, magnitude RMS squared. And Q would be X, the I, RMS squared. So we have this formula. So in this case, because we have the current RMS, the magnitude, basically I RMS, the magnitude is squared. And we have Z basically based on each part, we know the R and X. For example, here ZAB, we know the R, we know the X. So therefore, we can easily use this formula. Let me expand my paper. Okay. So for example, for P, the average power associated with AB. So let's say from A to B will be the R equivalent between A and B times the I, again, RMS squared, and the R, A and B, the R is 2. So the whole Z was 2 minus J, right? 2 minus J. So R was 2, X was negative. So R is 2 times the magnitude RMS squared, 12 squared, that's what. Now Q, I guess in the next part it says also reactive power associated. Okay, if I want to find Q, AB would be X times RMS squared. And in this case, X is -1 times 12 squared. And here we have And we can do the same for BC, ZBC. Okay, Z of BC was 1 plus 5j, right? Z of BC, 1 plus 5j. So the R is 1, the X is 5. So again, as before, P of BC would be R times the same current, 12 squared, and Q would be X 12 squared. And last one, P and Q relate associated with Z of L. Okay, we have the whole Z of L, which is this. Again, this is R, this is X. We can easily find P and Q.